Okay, I think we're going. So, all right. So, section 1.1 is about lines. Like we said, this is going to be a lot of review, but there's going to be a little bit of change in some of the vocabulary. And the first thing that we're going to talk about that is a little different, but it's something you've seen before, is called coordinate increments. And basically, coordinate increments refers to change in x and change in y, which is kind of the building blocks of how we would do slope later. Okay, and we're going to use the Greek letter delta. Have you guys all seen that before? Familiar with that? The little triangle means change in. Okay, so delta x is the change in x. So if we have two x coordinates, it would simply just be the difference of them, x2 minus x1. Okay, that's the coordinate increment of x. And then the coordinate increment of y, same thing, simply be the change in the two y coordinates that we would have. Okay, so as an example then, we're going to find the coordinate increments between -3, 1 and 4, -2. Okay, now, it kind of depends on which order you're going. So there's two sets of answers for this. So can somebody give me what they believe is the answer for delta x for this example? 7. Okay. Because if we go from -3 to 4, we got to go up 7, right? You can do it that way. Or you can think of it as 4 minus -3. If we just do the subtraction, that's also 7. Okay? So I'm going to write it out that way. Okay. Now I said that's one answer. There's technically another one. If I had looked at it a little bit differently, what's another answer I could have come up with for delta x? -7, right. Depends on the direction you want to go with it. So, say, or delta x could have been, and if I subtracted those two numbers the other way, -3 minus 4, I get -7. Okay, and so delta x, or delta y rather. Okay, if I'm doing this same kind of thing, let's subtract in the same order that I did the delta x right above that one. What should be my coordinate increment for y there then? -3, right. -2 minus 1 is -3. So if I, again, flipped it around, the delta y would be then 1 minus -2, which would give you a +3. Okay? So usually they're going to say from this point to that point. Okay? So if we did it, another example here, and we did the same question, but let's go from 3, 5 to the point 4, 8. So that kind of indicates a specific order or direction that you're going with it. Okay? So from 3, 5 to 4, 8, what would be the coordinate increments then? What would be the delta x and the delta y? So 3, 5 is like your starting point. 4, 8 is your ending point. What do you think? be 1 and 3. Because this is kind of like your x2, and this is your y2, right? Because that's the second point you're working with. This is your x1 and your y1. So you'd be subtracting this minus this. So this would be 4 minus 3, which is 1. And the other one would be 8 minus 5, which would be 3. So with that indicated direction, it has to be that to make it work. All right. So let me scoot this up. All right. So creating equations. That's the other thing that we're going to be working on quite a bit here. So given some information, can you produce an equation? Okay, and we're going to talk about all the different forms of linear equations that you guys studied in the past as well. Okay, so start with the one that you already know well. Let's say we know the slope of the line has to be 3, and we would like to pass through the point -4, 5. Okay, so how would you guys attack that one? First of all, what form of an equation would you want to use for this? What form of a linear equation? Give you a hint. The first piece of information should kind of lead you there. Slope-intercept form. Yeah. So let's jot that down if we don't remember it right off the bat here. Y equals mx plus b. M is your slope, b is your y-intercept. So what can I do with this now that I know the information I have up top there? We can replace the m with a 3 at least. We can start with that. Passes through the point -4, 5. So how am I going to use that information? Yeah, we can plug that in for x and y, and that'll allow us then to figure out the b, to find the y-intercept. Okay, so bring it up over here now. So the y is 5. The x is -4. So 5 equals 3 times -4 plus b. Solve that for b. Let's see if I'm doing my math here right. I'm getting 17. Yeah. Does that sound right? So it'd be -12. You add the 12 to the 5, and you get 17. Okay, so my equation here then is y equals 3x plus 17. And that is in slope-intercept form. Okay, which is the first form you guys learned and probably did like 90% of the time when you were in Algebra 1, and even moving forward to some degree. So now we have this one in slope-intercept form. Let's see if we can convert it into another one of the forms you guys are going to use, and that's point-slope form. And I won't make you guys recite this one from memory, but I'm hoping at least this one looks somewhat familiar. Does it? Just a little bit, yeah. Y minus y1 equals m x minus x1. So in this one, this is another way we could do the same exact problem. If we have a slope and a point that we know that goes through, we can just plug all that information right into this one to start with. Okay, we don't have to go through the solving for a variable like we did the last one. Okay, both methods are fine. It's just a different way to do it. So with this one, we could plug in y minus 5 equals 3 times x minus or plus 4. And if you were to do the distributive property and add the 5 to the other side and all of that, you'd end up with the same equation we just had, right? Y equals 3x plus 17. It gets you to the same place. I might ask for slope-intercept form. I might ask for point-slope form. So this might be what I'm looking for in the problem. It just kind of depends. So I'm going to just highlight it as the point-slope form of the answer as well. Okay, so it might give you some information that you have to create an equation for, either slope-intercept form or point-slope form. Another form that we've worked with in the past is standard form. So I'm going to take a minute to quickly talk about that as well. So let's say a line has x-intercept, has an x-intercept of 2 and a y-intercept of 5. Write the standard form. Equation. All right, so standard form looks like this. AX plus BY equals C. And again, that should be one that looks familiar. Probably didn't use it a ton, but it has its uses, which we'll delve into some more a little bit later. But if we want to get it to here, and A, B, and C don't really have any physical meaning as far as what you're seeing on the graph, that sort of thing. So we can't start immediately with this one like we kind of did with the other ones. So we're going to have to start with another form that's going to allow us to get an equation written out, and then once we have that, we can do some algebra and convert it so that it looks like this, so it's in standard form. Okay? So if I have an x-intercept and a y-intercept, physically on the graph, what do I really have to work with? What is an x-intercept and a y-intercept? They're points, right? They're points on the graph. So I have 2 points to work with. Well, what 2 points do I have? If I have an x-intercept of 2, what point is that? What are the coordinates? 2, 0. Okay. So I've got 2, 0. And then I have a y-intercept of 5. So what's the point for that one? 0, 5. Okay. If I use one of the other two forms, slope-intercept form, point-slope form, what do I need to have for both of those? Slope, which I don't have yet, right? But I can calculate it, right? How do you calculate a slope? Okay. Rise over run is one way that we've described it in the past. Another way to look at it that kind of relates to what we've been talking about today so far. M is the change in y over the change in x. It is the rate of change of y to x. All right, and delta y and delta x, those are those increments we were talking about. Okay, so what are the increments of y and increments of x? What's the change in y? What's the change in x? And you can pick a direction. I want to go. Let's say we want to go from this point to this point. Okay, so what is the change in y? 5, okay. And what's the change in x? -2. So our slope is 5 over -2. And if I want to use any of the other two forms we talked about, what's the other thing that we need? You got to have a slope and you got to have a what? Okay, yep. If we did slope-intercept, we could go right to the y-intercept. Just need a point, right, of some sort. But we have a y-intercept, so we could just throw this thing right into slope-intercept form. That's true. I hadn't thought about that. So the y-intercept is 5. The slope is 5 over negative 2. So, kind of running out of space, but I'll see if I can squeeze it in. So y equals negative 5 halves x plus 5. Okay, so I've got it in this slope-intercept form now, and I want to make it look like that. Ax plus by equals c. So now we're down to just algebra. What do I need to do to this thing to get it to look like that? And by the way, it's important to note, in standard form, the a, the b, and the c are all integers. Can't be fractions. Okay? So that being said, what do you think I should do next here? Yeah. Get rid of the fraction. Multiply it all by 2. So if I do that, I've got 2y equals negative 5x plus 5. So we're close. What do I need to do to finish it up? Oh, right. Yep. Darn, my very first video and I make a mistake. Jeez. 10. Yeah. Okay. So what's left? There you go. Yeah, the minus 5x, we just got to add that over to the other side. So we'll end up with, come on, 5x plus 2y equals 10. And now we're in standard form. Do you guys remember doing like matrices and solving systems of equations last year in pre-calc? Okay, that's where standard form comes into play. Do you remember when we did that? The equations you were using, they look like that, right? That's where these get used. Okay, generally when you're talking about like stuff like this, you don't want to write it like that. Okay, if we're doing like the cost equations and things like that, standard form doesn't make a whole lot of sense because it's hard to pull out any meaningful information. But if we're solving a system of equations that involve some of this stuff, then you're going to want to convert it because that makes the algebra easier, and you can build matrices and that sort of thing or whatever. So, like I said, it has a place, but for most modeling situations, we're not going to be real concerned with it. So, one last question I want to have you guys do here, or one example, is what if I give you some information, equation rather, and I ask for some specific information about it. Okay, so for example, let's find the slope and y-intercept and I'll give you a couple to do here. So first one, we'll do it in standard form, 2x minus 3y equals 12. And then the second one, we'll do point slope form on that one. Okay, so 2x minus 3y equals 12, y plus 7 equals 3 times x minus 1. We want to find the slope and the y-intercept. So what do you think is going to be the strategy to answering this question then? Those are the two things that I'm looking for, the slope and the y-intercept. Slope, intercept. Slope, intercept. Slope, intercept. Put it in slope, intercept form. Right. Okay. So, what do I need to do to get it in slope, intercept form? What's the algebra I should take? Okay, subtract the 2x. So we've got negative 3y, and I'll just put the negative 2x first, just so we're starting to look the way we want to look here. Negative 3y equals negative 2x plus 12. Okay, and then? Yeah, divide everything by negative 3. So y equals, this would be a positive 2/3 x. 12 divided by negative 3 is negative 4. Okay, so in the slope-intercept, we've got 2/3 x minus 4. Now that it's in slope-intercept form, I can pretty much read the answer right off the equation. What's the slope? 2/3. What's the y-intercept? List it as an ordered pair if you want, 0, negative 4, or you can just write negative 4. So, the next one. Same goal on this one, right? Got to get it into slope-intercept form so we can read it off. Okay, so where shall I begin here? Okay, distribute the 3. Y plus 7 equals 3x minus 3. Okay. And then what? All right. So that would be minus 10. All right, so we're in slope-intercept form now. So what's the slope? What's the y-intercept? Negative 10. Okay. One thing to point out on this one, too. Notice how we talked about with point-slope form. The slope goes right here, right? That 3. Notice how when you had it in slope-intercept form, the slope's still a 3, right? When you distribute that 3, that slope is still in the right position for the slope-intercept form, so it should not change. When you convert from point-slope to slope-intercept, that should not change because it's still the same slope. It's 3. Yep. So, good. All right, so that's everything that I wanted to go over with you guys as far as the notes with this stuff. Tomorrow, what you're going to do is you'll take a self-assessment that I have over converting from different linear forms, okay? And then you're going to have an assignment out of your textbook as well. So that would be what your online day would look like for tomorrow, okay? If we were in an online format right now, okay, I'd be done today with everything that I need to meet with you guys about, and then tomorrow you'd be doing that stuff on your own at home. But we're going to still come in tomorrow because we haven't got anything set up yet. But